All right. Sorry I couldn't be with you guys today, but we're going to actually press on with our notes. You'll probably find that solving these equations that we're going to solve today aren't too bad. There might be a couple that trick you up a little bit, but that's okay. So we're going to go through these notes. They're on page 23 in your packet. And then I'll give you a chance to practice, and you can have access to the solutions key to help you out. We will be solving equations all week, so if there's some that you have questions on, we can talk about those tomorrow, and we'll just see more and more equations this week, all right? Okay, so the very first equation, we're going to solve for angles that are between 0 and 2 pi. So we don't have to worry about anything bigger than 2 pi, and we don't have to worry about anything less than 0. And if one of the answers is 0 or 2 pi, we're just going to use the 0 because of the equals to. We're not going to use the 2 pi itself, right? So the first question is saying, hey, cosine of theta, where does that equal -1? And so if you look at your unit circle, so grab your orange sheets and look at your unit circle. Remember, cosine is the x-coordinate. And if you look at all the x-coordinates, right, there's only one place where the x-coordinate is -1, and that is at pi. And so the solution to this equation is that the theta, the angle, has to be equal to pi. And that's it. They get a little bit harder, but that's kind of the main idea here. All right, so the next one says sine of theta equal to 0. So where is the sine equal to 0? So go back to your unit circle. And if you look on your unit circle, remember the sine is the y-coordinate. Technically, it's here, right? And so we'll say 0. And then the other place is over here as well. So pi is the solution also. So we have two solutions, both 0 and pi. So theta equals 0 and pi. Now, we're not going to include 2 pi because of the whole equals to thing that we talked about earlier. All right, up next, a little bit more complicated because there's something going on in front of the tangent of theta. So we have to do a little bit of algebra before we actually jump to our unit circle. So we need to get rid of this 1/3. Right now it's being multiplied, and so you can divide by 1/3. When you do 1/3 divided by 1/3, those will simplify, right? And we'll be left with just the tangent of theta on this side. And then remember, if you divide this side by 1/3, you also have to divide the other side by 1/3. And -1/3 divided by 1/3 is just -1. So for this question now, we're asking ourselves, where is the tangent equal to -1? So go to your unit circle. Remember, tangent is sine over cosine. And so when we talk sine over cosine, that means it's where the sine and the cosine are the same, but one of them is positive, one of them is negative. So if you're in Q1 and you look at sine and cosine, they're the same here, but when you divide it, you get 1, not -1. Over in Q2, when you divide them, you get a positive and a negative, so you'll get a -1. So 3 pi over 4 is one of our answers. In Q3, they're both negative, so when we divide, we'll get a positive, so that's not it. So then the other one here, one's positive, one negative. When we divide them, that'll be -1. So 7 pi over 4. So two solutions, 3 pi over 4 and 7 pi over 4. So we'll just say that theta equals 3 pi over 4, 7 pi over 4. All right, next one. -5 plus the tangent of theta equals, this is a hot mess. Now, whenever you have a big fraction and you have multiple things on the top and just one thing on the bottom, you can split this up into both pieces divided by 3. So -15 divided by 3 is just -5. And then negative square root of 3 divided by by 3, we would just leave that, right? Negative square root of 3 over 3. And then we have -5 on this side, plus the tangent of theta. And so if we're going to solve for the angle, we're going to figure out what the tangent of theta, what it needs to equal. You can go ahead and add the 5 over, which will make the 5 simplify on this side to 0 as well. So we'll just be left with tangent of theta equal to the negative square root of 3 over 3, this value. And so we'll have to go to our unit circle and figure out negative square root of 3 over 3 for the tangent. All right, so remember that's what happens when we do one of the simplifying, right? So you have these written on the side of your unit circle, and so we're looking for this one. So its tangent is sine over cosine. So we're looking for where the sine is 1/2 and the cosine square root of 3 over 2. So this is the y and this is the x, and we need it to be negative, so they have to have opposite signs. So where's the sine 1/2? So sine is the y coordinate. So here, but when we divide, we won't get opposite sign, or we won't get a negative because they're the same sign. The next place we're at a half is here. When we divide, we will get a negative. So that's one of our answers, 5 pi over 6. Down here is the next 1/2. But when we divide, we'll get a positive because they're both negatives. And then the next one way over here, when you divide, you will get a negative there. And so that's our other answer. So it's 5 pi over 6 and 11 pi over 6. So our final solution for our angles, 5 pi over 6, 11 pi over 6. All right. Next one, we have 0 equals 4 plus 8 times the sine of theta. And so once again, we're going to solve for the sine of theta. So we have something being added and we have something being multiplied. So just like a regular two-step equation, you're going to have to take care of the adding, subtracting first. So subtract 4 to both sides. Negative 4 equals 8 sine of theta. Next step is to divide to get rid of that 8. So divide by 8. So this is negative 4 over 8, which is negative 1/2, is the sine of theta. So we're asking ourselves, where is the sine equal to negative 1/2? What angles is that true for? So I'm going to pause. You go to your unit circle and you figure out what angles those are. All right, so let's check and see how you did. We're looking for where the sine is a negative 1/2. Well, sine is the y coordinates, and it has to be a negative 1/2. So it's not this one. It's not this one. It is this one down here, 7 pi over 6. And over here, 11 pi over 6. So your solutions should have been 7 pi over 6 and 11 pi over 6. All right, up next, we have 0 equals 3 plus 3 tangent of theta. So first thing you're going to have to do is get that tangent by itself. So subtract this 3 over, just like a two-step equation. So negative 3 will equal 3 tangent of theta. And then divide both sides by that 3 in front. We'll have negative 1 equals the tangent of theta. And just like on the last question, I'm going to pause and let you figure out what angles have a tangent that is negative 1. All right, so this is going to happen when sine and cosine are the same thing, but different signs, right? So same things are when they're both square root of 2 over 2. So any kind of pi over 4, right? 3 pi over 4, 5 pi over 4, 7 pi over 4. And you need the ones where they have opposite signs. So that's at 3 pi over 4, we have a positive and a negative. And at 7 pi over 4, same thing. One's positive, one's negative. So 3 pi over 4 and 7 pi over 4. All right, last two examples. So we have the sine of theta plus pi over 4 equals the square root of 2 over 2. And so this right here is going to make this equation just a little bit more complicated. And so because that pi over 4 is inside of the sine function, what we're first going to do is we're going to figure out what angle makes the sine equal to the square root of 2 over 2. So what angles give us square root of 2 over 2 for sine? So let's go to our unit circle. The sine value is the y-coordinate. So the first place the sine is the square root of 2 over 2 is at pi over 4. And then the other place is over here at 3 pi over 4. So your options are pi over 4 and 3 pi over 4. Now that's not what theta equals. That's not what this theta equals. It's what the theta plus pi over 4 equals. So both of these are theta plus pi over 4. And the two options for what they could be is pi over 4 and 3 pi over 4. So whenever you have this extra step inside of your trig function, you're going to first figure out, hey, what angles do I have the sine equal to the square root of 2 over 2? And that's what we have here. And then inside, what was inside of the trig function, we're going to put here and here on the other side of our equal sign. We're going to continue to solve. So we would subtract pi over 4 from both sides. And so over here, we'll just have a theta equal to 0. And then on this side, we'll have theta equals, if you subtract pi over 4, that would be 2 pi over 4, which is just pi over 2. And so here's what's happening. If you take each of those and plug them back in, you would have to do the plus portion first before you take the sign. So for example, if I plug in 0, 0 plus pi over 4 is pi over 4. The sine of pi over 4 is square root of 2 over 2. Same thing on this side. If you plug in pi over 2 for that angle, pi over 2 plus pi over 4 is 3 pi over 4, right? It's a half plus a fourth, which gives you 3/4. And the sine of 3 pi over 4 is square root of 2 over 2. So when there's this extra step in there, it makes it just a little bit more complicated. All right, so I'm going to pause and I'm going to let you try number 8 completely on your own, and then we will go over it and see how you did. All right, so when you go to solve, they both have to have a theta plus pi over 3 and a theta plus pi over 3. And you're trying to figure out where is the cosine equal to negative square root of 2 over 2, because that's what these two are going to equal, all right? And so cosine, negative square root of 2 over 2. If you go to your unit circle, cosine is the x-coordinate, right? And so x-coordinate, negative square root of 2 over 2 at 3 pi over 4. And then it's also negative at 5 pi over 4. And so your two options is that those can add up to 3 pi over 4 or 5 pi over 4. And then to finish these, you're just going to do some algebra. So this plus pi over 3, we're going to subtract pi over 3 from both sides so that we get just our angle that we're looking for. And here's where you have to get some common denominators. So you're trying to do 3 pi over 4 minus pi over 3. Common denominator here for those two would be 12, right? So for this first one to turn into a 12, you have to times by 3. So times the top by 3, so it's 9 pi over 12. For this one to become a 3, you times by 4, so that's 4 pi over 12. And 9 minus 4 is 5 pi over 12. So your first angle, if you were to plug it back in, is 5 pi over 12. So if you take 5 pi over 12, you add it to pi over 3, you're going to get that 3 pi over 4. And then when you take the cosine of that, you'll have negative square root of 2 over 2. All right, and then this one here, we need them both to also be 12s, right? So 12, that one you had to times by 3, so this would turn into a 15. 12 here, that one has a 4 on the top. 15 minus 4 is 11 pi over 12. And so if you were to take the 11 pi over 12 and plug it in and add pi over 3, if you were to get common denominators there, add them together, you would end up with what we originally had, which was 5 pi over 4. And then the cosine of 5 pi over 4 is negative square root of 2 over 2. All right, we will be solving equations the rest of this week. They do get slightly more complicated. We're going to solve them all the way up until Thursday, and then I think I have a quiz for you on Friday. So I will be back tomorrow, and we can go over any questions that you have. In the meantime, your homework is on the next 2 pages, 24 and 25. So it'll be 1 through 18. And I have the solutions, the whole packet. And so this will be sitting on my desk somewhere. Hopefully y'all can find it. It has all of the graphing solutions in it too. It's that big packet that you've been checking with for the past week. And so if you can't find it, search through some piles. It should be there somewhere. And you can use it to check your solutions as you're going through, all right? If you have any questions that can't wait till tomorrow, go ahead and shoot me an email. But if not, I will see y'all tomorrow, and good luck.